Okay, so what I'll be teaching today is reduction of a system to a single force and moment. And so what we have here pictured is some sort of structure, right? And it's got three forces acting upon it: force 1, force 2, and force 3. And we're given the magnitude of each force and the direction of each force. And what we're asked, and each force, by dimension, is rotating around this point O. And so what we're going to do here is we're going to simplify the we're gonna simplify these three forces into one force and the moment into one moment, so we can analyze it better. And so what we need to do first is break each force down into its x and y components. And I'm going to use a color coordinate system. And so I'm going to have 1, 2, and 3. So F1 of x. F1 of x, right, is going to be, okay, so F1, we're going to break it down into its x component. So since it's going straight down, there is no x component. It's not going right or left in any sort of way, it's going straight down. And its y component is going straight down, right? So all of that magnitude is in the y direction, in the negative y direction, because we're on an xy plane here, and so the up is the positive y direction, so down is the negative y direction. Negative 30. Okay, so we're gonna find the s component of F2 now. So this is a 3, 4, 5 triangle, and so what you can do here is you can say that 60 is equal to 5 as the negative x component is equal to 3, and the negative y component is equal to 4. All right. So what we're doing here, we're looking at a bigger triangle compared to this small triangle. The relationships are the same between the numbers, so that's why we can do this. So 60 times 3 over 5 equals negative 60 times 3 over 5 is x, and negative 60 times 4 over 5 is y. So x is going to be negative 60 I'm going to back up. So I didn't really explain why these are negative, and they're actually not. So in moments, if the rotation is negative, if it's clockwise, right? If it's clockwise, it's negative. If it's counterclockwise, it's positive. So clockwise equals negative. Counterclockwise equals positive. So since our x is going this way, it's actually going to be positive, and our y has no rotation, so it's neither positive nor negative, and I'll explain that more later. But for now, just know that since X is going in the counterclockwise direction, it's positive. And so X is going to be 60 times 3 over 5, and F2Y is going to be 60 times 4 over 5. Okay, so now we're going to break down the third one, F3. Its X component is the only one. It's 40 pounds going clockwise. Therefore, it's negative 40 pounds going clockwise. And its Y component, it's just like F1's X component. There is no Y component in F3 because it's going directly in an X direction. So that one's 0. Now we can, in order to find the moments, right? We're gonna have to take the sum of the forces in each direction, right? To simplify it down. And so the sum of the forces in the X direction is going to equal something, and the sum of the forces in the Y direction are going to equal something. Okay, so what I did here, I added up all the X components. 0, 60 times 3 over 5, negative 40. Alright, and then I got an answer, which is our resulting force. It's X component. Right? What we're doing, we're trying to find a resulting force. So its X component is negative 4 because that's what all the X components of the 3 up there added up together is. So same thing with the Y component. It's negative 30, 60 times 4 over 5, and 0. Added up is 78 J hat. And so that actually is the force, those 3 forces added together is going to equal, so the resulting force is negative 4 I hat plus 78 J hat. But now we have to find the moment. So we just summed up the forces. Now we need to find the moment of, we need to find this button. To simplify these 3 forces into one moment, we have to find the sum of the moments of each force. And so the sum of these moments is going to equal each of these things. Each term is going to be this equation right here. We're going to find the moment for F1, F2, and F3 and sum it up right here. And so the moment of F1 is going to be its distance times its force. Distance being the distance, the perpendicular distance of the component. And so I'll explain more here in a second, but let's do the first one first. So the X component of F1, its magnitude, the magnitude, the pounds of force that it's exerting is 0, and that's going to be multiplied by the distance, the perpendicular distance, and from from the point of revolution, and in this case it's 0, so that one's easy. So we're going to add that to the rest of them. So actually, its distance is not 0. So the x distances it's perpendicular. So the component is going this way, and the perpendicular distance from that component is this way. So the distance is actually 6, which since the magnitude is 0, it doesn't matter for that component. But I want to make sure you guys understand where I'm getting these numbers, so I want to explain that. So that's the magnitude of F1 of y, and its distance from point O, its perpendicular distance, is the component is going this way, so the distance is 0. And that is the case for every single y component, actually. And it'll make more sense when the numbers are up there, what I'm saying, but I'm gonna copy these numbers down in the same way, and then explain it after. Alright, so I just explained the blue part. Now the green part, this is the magnitude of the x component, and this is the distance from, the perpendicular distance from the point of revolution, 5 feet, 3 plus 2, is that 5. This is the y component of F2, this magnitude, times the distance from, the perpendicular distance from the point of revolution, which is 0. This is the magnitude of the F3x component times the perpendicular distance from the point of revolution, which is 2. And then this is the magnitude of F3y component times its perpendicular distance, which is 0. And so now these things added, this is this moment right here, if you calculated just the blue, it would be F1, the moment of F1, right? If you calculated just the green, it would be the moment of F2. If you calculated just the red, it would be the moment of F3. However, we want to simplify these moments into one. So we're going to take the sum of them. That's what I did here. So the sum of these moments is so this is multiplied by 0, so it's gone, that's gone, that's gone, and that's gone. And all we have to do is add that number and that number, which is 100. And so the one moment that we have to, the summation of those 3 moments is 100, and the label is pounds, feet, because we're taking pounds times feet. This force in this moment is this whole picture simplified.